Hello and welcome to our discussion on interval estimation. Interval estimation is all about finding what the average of a population will be. You see, because sometimes it's a little time consuming or expensive and might require the use of more human resources, finding the average of a population is a bit difficult. And so with interval estimation, all we seek to do is we find the average of a sample, and using statistical inference, we estimate two values within which we hope to see the population average. Now we are going to look at three main scenarios. The first scenario will be estimating the average interval for a situation where the population standard deviation is known. In the second instance, we'll look at what we call a t-distribution, which is more about estimating the average of the population interval in situations where we do not know the population standard deviation. We will then finish off this discussion by looking at how to find a sample size and then also how to estimate the interval of the population proportion in categorical situations. The first part of this video will consider the two sections or the first two sections of our discussion here, estimating population mean with known population standard deviation and with unknown population standard deviation. And so let's delve right in. You see, most of the times because it's super difficult to find a population average, what we do is we use the point estimate. We use our sample average, but our sample average cannot provide us with the exact value of the population average. And so what we are going to basically look at is we are going to estimate that our population average will be our sample estimate, our sample average with the possibility of a margin of error. And so we calculate confidence interval by taking the point estimate, which is our sample average, and then we add and subtract a margin of error. The margin of error here gives us the possibility that we might be a bit off on the positive or the negative side of our sample average. And so the whole purpose behind interval estimation is to give us some information about how close our sample average is to the population average. And like I said earlier, we'll be looking at two instances. The first instance is when we have the population standard deviation given to us. And the second instance is when we do not know the population standard deviation and therefore we will have to use our sample standard deviation. Now, because in most cases the population standard deviation is unknown, interval estimation with our sample standard deviation tends to be the most popular and the most applicable. And so we will refer to cases where the population standard deviation is known as sigma known, which is population standard deviation known, and cases where we do not know the population standard deviation, we will refer to as sigma or the population standard deviation unknown. But let's quickly review this. The whole idea here is to find the population average. But due to lack of resources and the time-consuming aspect of it, we do not spend more time to conduct a census where we ask everybody in the population. What we actually do is we estimate the population average, as you can see here, based on our sample average with the possibility of some errors. And so interval estimation usually deals with margin of error. Now let's look at how we actually calculate this. Our interval estimate of the population average is based on our sample average plus or minus the margin of error. This whole side of the formula is the margin of error. How do we calculate it? Our margin of error is calculated using three values. First, the population standard deviation, which in the case of an exam, you will always see the values submitted. The sample size, which is the actual number of participants that were collected from the population to study, and then what we call the Z critical value. The Z critical value here provides us an area of our significance level by 2 in the upper tail of the standard normal probability distribution. And so the first case of interval estimation we are going to look at is for a normal Z distribution. The second case where we do not know the population standard deviation will be considered as a normal T distributions. And so with Z distribution, we know the population average, and therefore we will estimate the population, we know the population standard deviation. And so we will estimate our population average using the population standard deviation. In the case of a T distribution, we do not know the population standard deviation, and therefore our estimate of the population average will be dependent on the sample standard deviation. Okay, so let's look at how we can find these values. Now, it's super easy to determine your sample size. So once we choose a sample out of the population, right, which will also be given to you in the question, we can calculate the values observed from the sample, and the average of the values will be our sample average. And so it's easy to know what the sample average is, what the sample size is, and in most cases in a test, you will also be given the population standard deviation. The big question, therefore, is how do we know our Z critical value or the Z alpha over 2 value? This value here is determined based on the confidence level. For each confidence level, we have an associated Z critical value. Now, because this is a basic statistics course, we are going to limit ourselves to 3 confidence levels: 90%, 95%, and 99%. And so if we are working on finding the population average with a 90% confidence level, we will use a Z alpha over 2 value of 1.645. If we are dealing with a 95% confidence level, we are dealing with a 1.960. And when we have a 99% confidence level, the Z critical value is 2.576. And so let's take a look at a quick example on how to estimate confidence interval using the formula we just discussed. Discount has 260 retail outlets throughout the United States. The firm is evaluating a potential location for a new outlet based in part on the mean annual income of the individuals in the marketing area of the new location. So what we are hoping to find is the average annual income. This we do not know. But based on our sample and the sample average, we will be able to estimate at a certain level of confidence what the average annual income of the entire marketing area will be. And so what did they do? Discount Sounds took a sample of size 36, so N, which is our sample size, is 36. The sample mean income is 41,100. That is our sample average. And the population is not believed to be highly skewed, so we believe the population follows a normal distribution. The population standard deviation is estimated to be $4,500. And so we know our population standard deviation, we know our sample size, and we know our sample average. The confidence coefficient to be used in the interval estimate is 0.95. And so our confidence level to estimate for the entire population is 95%, 0.95. The first thing we're going to do is to calculate the margin of error and confidence interval. And so we have been given these important sample statistics, study of discussed sounds. We have been given our sample size to be 36. We know our sample average is 41,100. We know our population standard deviation is 4,500, and we are working with a confidence level of 95%. Based on our formula, we're going to take our sample average and add and subtract our margin of error. So let's find the margin of error first, and then we'll add and subtract it from the sample average. A margin of error basically is equal to the Z alpha over 2, which is the Z critical value for 95%. From the table, 95% confidence level gives us a Z critical value of 1.96. And you can go back to refer, right? It's 1.96. So knowing our Z critical value, we will just substitute everything into a margin of error equation. Our Z critical value, or the Z alpha over 2 value, is 1.96 multiplied by our population standard deviation, which we know to be 4,500, divided by square root of our sample size. Square root of our sample size is 36. And so when we calculate this, our margin of error will be 1,470. Next thing we do is we're going to take this margin of error and we're going to add and subtract it from our average. And so at this stage, we subtract 1,470 from 41,100, which is the sample average. And we also add 1,470 to our 41,100. And so it gives us two values. And that's what interval estimation is all about. The two values are basically the lower limit and the upper limit. And so what we are basically concluding is at 95%, we are confident that the population average will be between 39,630, which is the lower limit, and 42,570, which is the upper limit. And so confidence interval estimation should always end up with two values, the lower limit and the upper limit. Now, I've got another approach to do this. If you have the recommended calculator, you should be able to also use the steps here to find your confidence interval estimate. There's a practice question here, and I would like you to spend some time on it. But if you look at the practice question, we are going to use a 90% confidence level for a given sample of size 50, the sample average of 145.59, using a population standard deviation of 1.67. And so at a 90% confidence, our Z alpha over 2, or critical value, will be 1.645 for a sample of size 50, sample average of 145.59, and a population standard deviation of 1.67. Go over this. We will discuss it when we meet in class. Okay, so let's go ahead and determine how do we choose between a Z and a T distribution. In most cases, when your sample size is very large, and by large, I'm looking at your sample size being greater than 30, we usually consider the distribution to be adequate. That means we can use a normal distribution. When the sample size is smaller, we tend to do more of a T distribution. But another thing also we want to consider is it skewed or not skewed? If your population distribution is highly skewed or has some outliers in there, choosing a sample size of 50 or more is the recommended number or sample size. If it's not normally distributed but roughly symmetric, a sample size as small as 15 should be okay. Now, what if we do not know the population standard deviation? You see, in previous discussion, we said when the population standard deviation is known, our margin of error is a Z alpha over 2 times the population standard deviation over square root of n, and we add and subtract that from our sample average to find the confidence interval. This next phase of our discussion is going to consider a situation where the population standard deviation is unknown. You see, when we do not know the population standard deviation, we should still be able to calculate confidence interval. This same question was asked by another gentleman in the past called William Gozet. William Gozet was an Oxford graduate in mathematics who asked the exact same question. To answer the possibility that the population standard deviation is unknown, we are going to assume what we call a T distribution. And this was proposed by William Gozet. When the population standard deviation is unknown, we assume or we estimate our margin of error using the sample standard deviation. But then, Applying the sample standard deviation means we are moving away from the normal z distribution to what we call a normal t distribution. As our confidence interval estimate is going to be the same thing, our sample average plus or minus the margin of error. But it's a slight difference in our margin of error here. You see, when we know the population standard deviation, it's a z critical value used. But when the population standard deviation is unknown, we use our sample standard deviation. However, it becomes a t distribution. Let's take a look at an example on how to calculate confidence interval estimate when the population standard deviation is unknown. A reporter for a student newspaper is writing an article on the cost of off-campus housing. A sample of 16 one-bedroom apartments within a half-mile of campus resulted in a sample mean of 750 per month and a sample standard deviation of 55. And so she chose a sample of 16, which is our sample size. The average cost of off-campus housing was $750. Without knowing the population standard deviation, our standard sample standard deviation was detected to be 55. Three important values. But no, this is very important. We are not dealing with the population standard deviation. We are dealing with a sample standard deviation. And when it's a sample standard deviation, it is not a z distribution, but a t distribution. And so here we're working with a t distribution. Let's provide a 95% confidence interval estimate for the mean rent per month for the population of one-bedroom apartment within a half-mile of campus. Here, we are going to assume that the population is normally distributed. The only difference is we don't know the population standard deviation, and so we will estimate the average using our sample standard deviation. So how do we do that? Our formula says take your sample average, which we already know from here as 750, add and subtract your margin of error. But our margin of error is a t critical value times the sample standard deviation over the square root of n. To find the sample standard deviation is always given in the question as 55 in this case. Our sample size is given as 16. And so we know the average, we know the sample standard deviation, and we also know the sample size. What we don't know is the t critical value. How do we find it? We need two values. We need what we call the degree of freedom, which is the number of ways we can freely choose from a sample, and our degree of freedom is always n minus 1 in this case. And so we take our sample size of 16, we subtract 1 from it, and that gives us our degrees of freedom. And then we take the confidence level. Based on the question, we are working with a 95% confidence level. And so what we're going to do is we're going to take the t-table, and a copy of the t-table is on Moodle. You can download it, or you can just Google t-table, a PDF version of it, and Google will give you a PDF version of the t-table. But we're going to look at the t-table, and we are looking for the t critical value using two numbers. The degree of freedom, which we calculated to be n minus 1, which is 16 minus 1, and that's 15 right here. And the confidence level for 95%, which is this one here. And so where these two values intersect, that gives us our confidence, our t critical value for the 95%. So 95% is over here. Our degree of freedom is right here. Where these two meet is the t critical value. So we are working with a t critical value of 2.13. Let's go back and perform our calculation here. And so we would take our average, which is 750, plus or minus our t critical value of 2.13 multiplied by the sample standard deviation. Remember, not the population standard deviation, the sample standard deviation. divided by the square root of our sample size, which is 16. So our margin of error will be 29.30, and then we'll add and subtract it from the sample average to get the two values. Now, let me take a little bit of time here to talk about adding and subtracting. When we say add and subtract, it means perform two calculations. The first calculation will be the 750 minus the margin of error of 29.3, and the second calculation will be the 750 plus the 29.3. And so we're looking at two values. This lower limit here, which is 720.7, and this calculation here will give us the upper limit, which is 779.3. And so all interval estimate questions should give you two possible values. I have a small practice question here. Spend some time on it. But remember, because we're dealing with a sample standard deviation, it's not a z distribution, but a t distribution, right? And so the whole interval estimate procedure at this stage is very simple. You ask yourself, can the population standard deviation be assumed to be known? If it is known, then it's a z distribution. And so this is how we will calculate the confidence interval estimate. If it is unknown, that presents a t distribution, and this is how we will calculate the confidence interval estimation. Take a look at these two and ask yourself, when do we use this formula and when do we use this formula? We use this formula when the standard deviation is known. The standard deviation of the population is known. We know what the population standard deviation is. This formula is used when we do not know the population standard deviation. And so understand cases when we use either of these formulas and apply them. All right, I'm just gonna end here and I'll see you in the next lecture video. Okay, bye-bye.